Today lesson is about the network topology and then about the transmission medium that we will cover in today class. So again, while you study the network or networking, so it's pretty important that you know about the different topologies being around, or you can say what is exactly topology mean, and also the transmission medium, that is very important as well. So again, both are very important topics, and being relates to the IT or network field, you must understand all those details and concepts related to this topic as well. So just begin. At the end of day, uh, what will be the outcomes? So here you can see that you can describe the physical layout of a network, what exactly mean by a physical layout, the designing of the network. Then you will be able to explain even the different transmission mediums we use in daily networks, what is a guided media or what is unguided media, and all those stuff that we will cover. Beside that, uh, we will also discuss some more details relevant to the medium or the topology as well. So just let's begin. This is the first slide. Uh, Basically, topology refers to the physical structure. Before we discuss these different types, so a brief definition of the concept will be the physical layout, or you can say the physical structure of the network. So I will write here, topology basically refers to the physical layout, or you can say the physical structure of the network, how the devices are connected and how exactly the network look like, how those wiring and all those stuff is met. So topology refers to the physical layout or structure of the network. And then we have these different types of topologies. We have the mesh, star, tree topology, bus, ring, and we may have the hybrid topology as well. And in the real world, you may not exactly see the exact type of topology. You may see a mixture or maybe a combination of these topology in the real world. But what key thing is important, that knowing the concepts about topology, that how mesh look likes, or what are the advantage of using a mesh or maybe a star topology, that's important. So that's why we will explain and discuss those things. Here you can see the mesh topology physical structure, and like the word says, a mesh. So here we can see that the devices, there are different devices which are connected, but in mesh topology, let me write here that we have extra links, means extra connections between devices. So normally in mesh structure we have the extra connections that are used to connect different devices. So why these extra connections are used? The main objective, or you can say advantage of using those extra connection, is that if, let's say, a connection between these two devices is broken or disconnected, still they may be able to communicate or connect with the help of this device, these this one, because each and every device or computer has a dedicated connection. So in a way we can say that if we lost one link, then we have the extra or the second link that is still there, so there will be no disconnectivity in the network. That is the main objective, or you can say in other words, if you see the advantage of mesh topology. So to create a mesh type of network structure or mesh topology, basically there are you can say a formula function that how many number of links I will require and how many numbers of the input and output devices will be required. So let's say if I want to connect these four different or five different computers with each other, but I want to configure a mesh type of topology, means I want to have extra links and extra ports. So then how many links I will require and how many ports I will require. So for that we have this formula function which says for the links n into n minus 1 divided by 2, and for the number of input output ports we have n minus 1, where n is equal to the number of devices we want to connect, the number of devices we want to connect with each other. That is exactly the same thing. So if we put the same scenario, let's say this is 1, 2, 3, 4 and 5. So we have 5 different devices or computer and we want to have a mesh structure. So if we put that in the formula, so let's say if n is equal to 5, so it will be 5 into 5 minus 1 divided by 2. So the first will be evaluated the bracket, so 5 into 4 divided by 2. So then comes the 20 divided by 2, so the answer will be 10. So it means that the result we required 10 links for the connectivity of these computers or devices. And to find out the number of IO ports that we required at each device, so n minus 1, so here we put again the value of n minus 1, so it will be 4. So here the number of ports, or you can say input output ports that will be required 4 at each device. So if we calculate the same right here, so if we count the connections, so you will see there are 10 different links between devices, 4, 5, 6, 7, 8, 9 and 10. These are the different links, and if you see one device, there will be 4 possible you can say input and output, 1, 2, 3, 4. So that is basically a full mesh structure of the mesh topology. And again, why we should use if we want no disconnectivity. But again, keep in mind that if you want to create a mesh structure for a large networks where there may be tens or hundreds of devices, so then you can think that how much cables or links will be required, how many input output devices will be required. So normally the installation is difficult, means you will require a lot of cabling and connectivity. However, once it is created, so then there will be no disconnectivity, and if a problem arises, you can easily identify or troubleshoot that problem. But beside that, it is expensive because a lot of cabling and connectors or other equipments will be required. So that is the basic concept of a mesh topology or mesh type of structure of the network. uh, yeah. Yeah, maybe they are computers, maybe they are switches, maybe they are routers. That is the concept of mesh. So if you want to connect computers, so this is just an example. Yeah, clear. Router, switches, maybe computers. It depends. It means that if you want to connect devices using a mesh topology. So let's say, for example, if I say I want to connect two switches with each other. Let's say I want to connect these two switches. SW means the network switch. So if I want to, you can say if I want to go with the mesh concept, so here the n value is equal to 2. So let's count the number of links. So 2 into 2 minus 1 divided by 2. So here we will see 2 into 1, okay, and divided by 2. So here comes 2 by 2 is equal to how much? 1. So if I connect, that is in a way a partial mesh, but to have a real mesh you need to have a second connection or second link. So if that is broken, this one is still there. That's the main idea. Clear? So it doesn't matter that you need to connect computers or you need to connect routers or switches. It is just that concept or thing that if you want to have a mesh topology, so the mesh topology concept says that you will have extra links, extra redundant links. Redundant means backup. So if one link is go down, the other link will take over. So there will be no connectivity in the network. Clear now? Yeah. Mm. P will be there. Means one link down, the other link will be there. Yeah, at least two connection if you would say. While if I say the internet, we are using the internet structure, the internet network. If you see, it is based on a kind of mesh structure. We are connected around the globe, that whole internet. So if from one side a cable or something kind of connectivity disconnected, still we may be connected to that particular network. So internet is basically also not fully I would say, but to some extent or to some partial way, it represent a kind of mesh structure. And any organization, maybe any company, any office, if they don't want that their network goes down due to the link breakout, so they can create that mesh structure. They can use extra links, but again it is expensive, especially for a large or a huge network. Just think of, let's say, let think of, if you want to connect 100 devices, then calculate the number of links and IO. Then you will see how much the installation become pretty, you can say, hard, and as well as the cost it may raise. Yeah, exactly. Yeah. Mhm. Yeah, it's the topology. Basically it represents the physical structure, that how you can create a network, or how a network may be designed, or the physical layout or the structure would be. But going through mesh, fully mesh is pretty much expensive, but you can have that partial mesh. Maybe somewhere you can have extra links, and somewhere you may don't have extra redundant links. So you can use a mixture of that. But it all depends whether the organization is able to have, you can say, to they can manage, they they have the budget, uh, they want the same objective, so it depends on them. Because more wire require more space, and with more space, you may require more accessories and more rooms within the building. So that's not, you can say, free. It will need to be paid. So cost is a major factor. Well, mostly in most cases, the next topology is the star. So here, like you can see, we have a central device that is normally referred to as a hub, or nowadays it is called a network switch. So in most scenario, or in most office network, you may see or observe, or may design or create this type of topology or network, where all the computers or the devices are connected to a central equipment or device, normally called, yeah, nowadays it is a switch. So still we can conceptually call it as a hub, but you can say the actual device in the real world is the network switch. So here you can see, like a star, I may not draw the star properly, but like you can see, we have that star type of icon. So normally we have that device, and from its different sides we have those devices and computers are connected. So that represent a star structure. So this topology may mostly appear in LAN, local area network, or offices. Yeah. Yeah, yeah, basically you will see that in a local area network. Okay. Let me give you some more detail about that. It is hmm? That is, now we are discussing is the star topology. So here I said that the installation and configuration is pretty much simple compared to the mesh, or maybe to some other topology which we may discuss after this. So you can have a central device, just plug in the cables to the computers and to that central device, and that's it. They will be connected. So pretty much easy, and you can say simple installation of the particular topology that appears. But again, as you see, what will be the drawback, or you can say the major concern for this particular type of topology? Can you point out? I said that this type of topology is pretty much simple and easy and mostly adopted in a local area network, but what will be the major disadvantage or problem with this topology? Can you mention? Yeah. Hmm. How you can say that the network will be slow? Well, if you have hundreds of computers, there is no issue. No. If that device gets out of order, see what will happen. All the devices, the computers are down, no network connectivity. So that's the major issue. If that central device uh, have some issue or problem, or it's go down, so it means all the computer will lose connectivity. So that's the major concern about this topology. Okay. Hmm. No two switches. No, no, no. It's not the solution because the computers will be connected to a particular switch. Once you move into the more advanced concepts, like more advanced networks, so there you will see that multiple computers may be connected to one switch, but they will be logically divided. They will be logically divided. If you heard about the concept of or the name of VLANs, that is what we used in the real worlds. So the switch may be one, and it's not that regular that this switch will always become off or maybe down. It's just a matter of you can say concern, or you can say a point that may be known to you, that if the central device gets out of order, so the computer may lose connectivity. And you said that we may have slow network communication, so that is not an issue because we have fast ethernet switches, and nowadays we have the giga ethernet switches as well, gigabit, so they are pretty much fast. The fast ethernet can operate 10 by 100 mbps, so that's a quite a good amount of speed, whereas the gigabit can operate, depend it's on the type, maybe 100 by I am just giving an example, mbps, maybe 10,000 if it is a fiber or something like that operates. So we have those fast switches, those fast ports in the switches. So that's not an issue of the slow network communication or connectivity. Well, for a LAN, let me say again, if you want to configure a local area network, just a local, you need that device only. And if I would say, if you want to connect, if you want to connect multiple lanes, or I would say different local area networks, so if you want to connect different local area network with each other, then you will require router or maybe routers, if I say to multiple. But in case a single lane or same network, no need of router. Yeah, in most cases you will face this scenario, the one I am circling at the moment. Yeah, that will be faced in the real world, but depend again. Sometime you may not require. Yeah, if you connect multiple switches with each other, no need of router. If they are on the same network, no need of router. For for increase computer for increasing computer more and adding more and more computer, you will require switch to add another switch, as long as you remain on the same local network. No, 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 it's not like that. It's not like that. Remember, I think I gave you a simple example of, I think I gave you I don't remember, but I think it was Seattle and New Jersey, I think. What about? Well, so if you have a 200 laptops, okay, so again, pay attention to my words. I am saying that if you want to connect them all to the same network, means they may be part of the same network, local area network. You don't want them to be divided logically, to be separated from each other on the network point. So then you will require switches. Okay, but if you want to divide them into multiple networks locally as well, we can do that. If you want to divide them locally to multiple networks, like let's say we may have different departments, like these 200 computer belongs to, let's say, XYZ company. There is an XYZ company to which those 200 computers belong. So those 200 computers may be part of a, I would say, different departments, like the HR department, like as we are the IT department, the finance department, the administration department, and so on, etc. We may have a lot of these departments. So maybe you want to separate the HR department from the IT because their job responsibility is different. So you may want that HR communication or data may not be available to IT people or finance or admins. Similarly, the IT may not be accessible to all these other. So for that reason, you no, no, not group policy. You will logically divide them in the physical network. I am not moving towards that group policy thing. It is on the server level. I am talking about at the network at the moment, the physical or the exact network. So logically, we will divide them. And how we will divide them? We did not cover no, no, we did not cover IP addresses at the moment. So basically, you will have different IP addresses. Maybe for the HR, you may be using 192.168.0.0 slash, I'm just saying for example, slash 26. And maybe for the IT, you may be using 192.168. Let's say for example, I'm saying 32, sorry, 0 dot 32/26 maybe, or whatever. I'm just giving an example. So again, this is a different logical network, and this is a different logical network. Yeah, it is an IP address example. So it's a different network. It's a different network. So in that scenario, you will require routers. So they will be able to communicate with each other. Clear? So that thing you will learn more once you move into the CCNA. You move into there, and then from CCNA you move into the CCNP. So you will have that clear picture, then more advanced and more stuff like that. Okay, then we have another topology that is referred to the tree topology. So in a tree structure, we can see we have a multiple star topologies. Like the different star topologies are connected with each other using another central kind of device that is called the central hub. So let's say it is the HR office, it is the IT department, and let's say it is the admin department. So all these computers are part of the same organization. So to connect these different departments on the same network, we required a central switch or a central device. So that structure, or you can say, yes, it is a basically switch. Boxes represent the connectivity point, but it is a network switch that may be used to connect those computers with each other, or those different switches with each other. Okay. Yeah, it may be communicating with each other. Here you can have then a router. So if you want to configure them with a different, basically we are referring at the moment to the physical layout or the physical structure, that how a network may look like, or how it the physical structure may appear. Well, at the moment these are concepts. At the moment we are discussing concepts, and at the moment you need to understand those concepts. But as I said, in real world you may not see or practice exactly the same way. In real world it depends, because theories and real world may have some differences, but some will be seen and observed. Like is for example, if we let me move in back to that star concept, the star topology concept. So if I say right here, it appears to be very simple, that you are in a room and you want to create that structure. But think of a room, let's say let me draw a room here to have that clarified for you from real world. So let's say this is a room space. Let's say you are four different colleagues or five different colleagues in the same room. You are sitting and working. So maybe uh, you all sits right here, right there in this straight away, 1, 2, 3, and 4. This is 1, 2, 3, 4. Here your computers are connected to that switch. But again, you are not sitting in a way like the star. Your computer are not supposed to be in a shape of star. You are sitting in a line, or you can say in a row way shape. That would normally be in real world. But again, the thing important is that still you will be using a central kind of device that may represent that concept, that you are using a star concept to connect those computers with each other with a central device. So this doesn't represent that it is a star. Does it represent a star? The example I the example I give, no, it's not a star. This is not a star. Exact star like this. It is not exact like this star. But again, it uses the concept of the star. So in real world, same thing may not appear exactly as like in books. It may be different, but the concepts and details are the same, are there. So we need to focus on the details and concept at the moment. Okay. Okay, here we can see another topology that refers to as a bus topology. It is an old type of topology, and it is just for concept or knowledge purpose only at the moment, because we no longer use this type of topology in our networks. It doesn't exist. But if you see right here in the diagram, you can see that we have a cable, main wire like this, that is the cable, and the devices or computers are connected to that particular cable. In past once we use a cable, we will discuss that in the transmission medium, that was the coaxial cable. So in computer networks in old time we use the coaxial cable, but with the invention or development of the twisted pair or UTP cable, we no longer require this cable. But as you know, from time to time technology improves, so not in past. So at that particular time, coaxial cable was used, and in coaxial we will discuss there are two types, thin net and thick net. So basically that main wire refers to the thick net, and the computers were connected like that, and then at the each end of that main wire we have a cable end, normally called a terminator connector. So here we have a terminator connector that ends the cable, and that tape refer to again a type of connector that was used at that particular time, and it was called BNC T connector or BNC T, that was used at that particular moment. So again, if you see, it appears pretty much simple and easy to install, but the main thing, or you can say the problem with this particular topology was that if you want to increase the number of computers later on, once you create the topology, you created the topology, you connected the computers, and that's done. But later on, after some time, you want to increase the computer, maybe it is 4, now you want to add 5th, 6th or 7 or 8 or maybe more. So again, adding multiple computer require again reconfiguration, reinstallation of the whole network. So that was the big issue in that particular network. The second thing in that particular network was that if that wire disconnected, maybe broken from some part or somewhere, it has a cut or broken area, so that whole network, that complete devices become disconnected from each other. So that was a match. Yes. What boxes? The yellow one, I said that yellow boxes, or you can say that yellow tape which was written, it is basically a connector. I write here a B and C T connector. B and C. Yeah, right there. This one. It is a B and C T connector. No, 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 not the walls. It is not like that. Let me show you on the internet. You may not see this. It's quite old. Let me Google that. So, yeah, it's an old connector. Not at the moment we have. So, if I type B and C connector for you, so here you may see the different types. Let me move to images, and here you can see those different types of B and C. This is basically the B and C connector, and the yellow you are referring to is this one. This is the T connector, B and C T. While it was used in computer networks at that time, but if I refer, maybe in your area it may be or maybe not. I don't remember. I don't have any idea even at the moment about the US, but in some parts of the world or area where we have that cable television network nowadays, cable operators provide that cable television network. So normally they operate, or their wiring operates as coaxial cable on coaxial. So normally from the outside they give you the connection to your television or to home using from the main coaxial via a B and CT connector, and then the connector which plug-ins to your television is referred to a B and C. Same like here to these computers. So that's what I can give you from the today type of use of these connectors are what, because in computer networks we don't use them anymore. It's no longer used. Okay. Okay, lastly, not lastly, but maybe we may have another one as well. But another type of topology that we can see is a ring topology. In ring topology, as you can see that the computers are connected with each other in a ring shape, or you can say a ring structure. Normally, the last device or the last computer is connected to the first computer, or you can say the last device is connected to the first device. So if I said this is the first device, this is the second, this is the fourth, third, this is fourth, and this is fifth. So you can say this is connected to the first one. So the last device connect to the first device. And in a ring shape, why it is called in a ring shape, because the communication in this type of topology occurs in a ring structure, same like this ring. There is a kind of signal which is called normally a token. In a ring shape we have a signal that is normally refers to as a token that circulate or move in this topology. It circulate like this. So it is used for data passing, or you can say transmission of data from one device to another device. So that's why this type of network refers to a ring topology or a ring network. But again, in the real world you may not see this type of topology as well, but in some time or in past we have this topology. So why we are referring or why we are discussing, because you need to know the present technology as well as from concepts and exam perspective you need to know the past topologies and technology as well. Lastly, we have a concept of the hybrid topology. So as you may heard the word hybrid, so by assuming the hybrid topology, you may refer to that it is a type of topology where different types of topology are connected with each other. So maybe in one department we may be using a bus topology, whereas in another department we may be using a star, and in the third we may be using a ring. So all these three different topologies are connected with each other, so hence they represent a hybrid structure of topology. So this is just from conceptual point of view, or you can say from understanding point of view. In real world it may appear or may not appear, but once you have different types of topologies connected with each other, so that refers to a hybrid topology. Like in computer we have the hybrid computer as well. Do you know the hybrid computer? Well, the hybrid topology, we have bus topology, there we have the ring, we have the star. So let's say this is the IT department. uh, uh, the ring is used by the HR department, whereas the bus is, yeah, a central device or maybe a backbone cable, and the bus is being used by the admin department. So we may have a central hub or device, or we may have a backbone cable which connect those different topologies with each other. But again I am referring from concept point of view, that if we connect those multiple topologies with each other, these different types of topologies with each other, so how it relates or to which type of topology they may refer. So it will refer to the hybrid type of topology. Okay, like as you know, in hybrid we have the analog computer you may heard about, and also you heard about the digital computer. So once the functionalities, or you can say the features of both, are combined into a third one, so that computer refers to a hybrid computer. Similarly, if we combine different topology types with each other, connect them with each other, that creates a hybrid topology. Simple as that. Okay, with that we comes into the conclusion of the topologies, or you can say a brief or maybe some more detail about those topologies. But now we have another important topic that refers to the concept of transmission medium. So just recall from the earlier classes we talked about the data communication system, and in the data communication system we define different components or elements of the data communication system. Do you remember those components of the data communication system? That what are the components of a data communication system? Can you name some of them? Pretty much important. Transmission medium. So these were the components, and the components we are at the moment is the medium. So by medium we means the transmission medium, and transmission medium is again a very key component, or you can say relevant to the network connectivity of devices. And there are two types of transmission medium or media, we can say. One is known as the guided media, whereas the other is known as or called as the unguided media. So these are basically the two types of transmission medium, or you can say media. So a guided media has a conduit. That's the word I can use. It has a conduit. Whereas the unguided media has no conduit. That's the difference, main difference you can say. So the medium which offers the conduit, CONDUIT, you can Google it. You may find what exactly mean by this word, but the guided media refers to which has a conduit. Means we have the directions known, we have known the its physical limitation as well. So like we have those let's say, if I say we have rivers, or we have those water canals that move around on the earth, so we can identify their directions, their limitations. So that's referred to normally the conduit concept. Like if you see a river in your area, so you may see that from which part of the land it curves and move around to its final destination, from where it starts and where it ends. Or let's say we have a water canal maybe, so from where it starts and where it ends, we can see its directions and limitations, start and end point. So that's normally refers to, we can use that concept to the guided media, where we can say that we can see the start point or end point, or at least we can see the directions, or we can or you can say that we know the limitation of that media, that how much long it can be used, for how much distance it can be used. So in guided media we have again two types of medium. One is made of copper, whereas the second is made of fiber or fiber optics. Whereas in unguided media we have those wireless mediums, means without wire, like we use those radios, waves, microwaves, etc. Like we use those Wi-Fi, WiMAX antennas type device. So any medium which is without wires is wireless media. Then in copper, again there are two types. So if we see, we can see that there are two types: coaxial, which is no longer used in networks, whereas we can use the twisted pair. Whereas fiber optics also have two types: single mode and the multi mode. Similarly, if we move to the coaxial have two types: thin net, as I said earlier in the topology section, and then we can have thick net. Then in the twisted pair we also have two types: shielded twisted pair or STP, and the second one is UTP, unshielded twisted pair. So again, if you see, guided media has two types of you can say material: copper and fiber optics. Then in copper we have coaxial and twisted pair. Then the coaxial have further two types as well as the twisted pair. Whereas in fiber optic we have those two different categories or type: the single mode and multi mode. Whereas in wireless we have different varieties, like the radio waves, microwaves, etc. We will see that once we move into more detail about the medium. But that is the, you can say, a summarized picture of the transmission medium or media that we normally use in our network. Okay. Okay. So here we start with the characteristics of the copper medium. Normally, still in networks we still use copper medium, but in copper we use the UTP and STP. Coaxial is no longer used, but as you see, the wire which is made of copper, copper is a kind of material that is being used in different cables. So the data is sent using electrical pulses, or you can say electrical signals. It has attenuation. The longer the signal travels, the more deteriorates. It means we can have problems or issues in the signal being traveled over a long distance. All copper media must follow strict distance limitations. So each copper medium has a maximum distance limit. Like if I said for a UTP or STP, so a maximum of 100 meters, a maximum of 100 meters can be used from one device to another device. So they have strict distance limitation. There are also a factor which is known as the EMI factor and RFI factor. The electromagnetic interference or the radio frequency interference. So they can distort and corrupt the data signal being carried by copper media. And to counter copper cables wrapped in shielding. To overcome. Also, there is a great, you can say, another problem that is called the crosstalk, which may raise problem in the signals being transmitted over the network medium. So to cancel that crosstalk, that's why we have those twisted pair cable nowadays. That's why it is not in coaxial. So in twisted pair we have that twist, so it reduce the problem, or you can say terminate the problem of crosstalk. But these are some of the main points, or you can say characteristics of a copper media. And here you can see the pictures, or you can say physical look of those wires, how they looks like or how they appear. So below you can see the coaxial cable. This is a coaxial cable, that black type. This is an outer cover, normally of plastic or maybe some kind of material. If you see this area or this portion, this is called shielding or braided shielding or shading. That is basically to reduce the EMI and RFI factor on the wire, to eliminate or reduce it, or to reduce that cross factor as well. So it is for that. Then we have another cover appear white like here. So normally it is made of PVC plastic or some kind of plastic material, and that's the main wire. This one, it is made up of copper. So that's the physical look like. Yeah. Well, it is no longer used in computer network. If I say it's no longer, maybe it may be used in cable TV still, or maybe in some old telephonic system, old telephonic system. Yeah, old telephone system. Still it may be used in some parts of the world. It may still be operational or exist, but in our area or the region I am in, no longer in computer networks, or maybe around the world, it is no longer, but still we can use them in cable TV network, or maybe in some old telephone network system. It may be still in operation, depend on the area where there may not be the latest technology or latest equipment. That can be because the world is large, and it doesn't matter that the latest technology exists everywhere. It may be not, but as far as computer network, it is no longer. So in computer networks we use either the twisted pair cable, and in twisted pair uh, it can be UTP, this is the UTP and this is the STP. So in UTP, if you see, this is the outer cover, and then we have those twisted wires in different color codes, these different. Whereas in the STP, this is the outer cover, and then we have a aluminum type or plastic shield that covers the main wires, like these wires, these are wires, the plastic color code. And then under these plastic wires, these, we have that copper wire through which the data is sent or received. So that's exactly the exact picture, or you can say the actual wires look like: coaxial, UTP and STP. If we talk about the UTP cable, so as I said, in most scenarios or in most network you may see or practically prepare or use this UTP cable in the network. With that cable we required an registered jack, that is called the registered jack or J45 connector, which is normally an 8 pins connector. It is an 8 pins connector. You may use it with your own computer or in office where you may be working. So that is being used, and it is this cable is used for connecting computers with each other. Again, there are 4 pairs of color coded wires that have been twisted together, to protect against signal interference from other wires, and color code add in cable termination. So let's say this is the wire, this is the UTP, so we may have one pair of wires right here, then the second pair of wire is twisted around with each other, then we may have the third pair twisted with each other, and then we may have the fourth pair twisted with each other. So that's what it says, and that's what exactly we use in the real world. Like you can see right here, you can see a more detailed picture or diagram of that wire. So here we can see the outer cover, that is called the outer jacket, that normally protect the copper wire from physical damage. Then we have those color coded wires, 4 color coded, like the orange, it is the orange color code. Then we have the green color code, green and white green. Then we have the blue color code, and then you can say what I would refer to this brown. Not black, it's brown. Normally it will be brown. So brown and white brown. So these are the 4 coloring scheme that are available. And then we have that twist. Normally that's referred to a twist, which is used to eliminate that crosstalk or interference of wires on signals. And then we have that color coded plastic, and beneath that we have that actual wire there. This is the actual copper wire that transmit the signals or receive the signals. So that is exactly the physical structure of a UTP cable. Then we have the STP as well. So STP provides better noise protection than UTP. If you want to have a better protection, noise protection means the protection inside the cable, means those electrons which travel inside of those wires they can have interference with each other. So if you want to reduce their interference with each other, then in an area or building where you may fear that EMI factor or RF factor has a great chance to also interact on the wires uh, beside the inner interaction of the wires, so there you can use the STP as well, but it is more you can say expensive compared to the UTP and a little difficult in installation as well. But again, it uses the same RJ45 connectors, that is an 8 pin connector, and 4 pairs of wire like we saw previously in the UTP cable. So it is same, but the main difference is only that extra shielding or that metallic shield that normally you can see here in the diagram. So we have an outer jacket right there. This is the outer jacket, again the outer cover. Then we have that shielding which was not present or available in the UTP. Then inside of shielding for each pair we have another extra shield, maybe foil shield, maybe plastic, maybe aluminum, depend. And then with inside each you can say shield we have those pair of wires twisted with each other. So that's the you can say the main difference between a UTP cable and STP cable. In UTP there is no shielding, whereas in STP we have that shielding. Beside that they are the same twisted pair cable, they have the may offer the same bandwidth and they have the same distance limitation, that is up to 100 meter between one device. So it means that if you want to connect two devices, so a maximum limit of distance between these two devices may be up to 100 meters, but if it increase above 100, then the signal may not travel properly, or you can say the signal may become weak with more extra distance. Other than that, they normally have the same thing in general. Clear? And also let me show you another thing. You may heard about the RJ45 connector. So basically this is the RJ45 connector. You may see that this is the connector 8 pins that is being used with the twisted pair, like you can see right here in this diagram. Okay, clear? We will discuss that configuration. We have standards for these. So basically here you can also see the UTP cable. Let me show you in more specifically. So if I show you, this is basically the UTP key cable real look. That's how it appears. Okay, you, you may have those built-in wires, like here you can see also. In these wires we have that actual copper. It is covered like this wire. This is the actual copper. These are color code plastic wire, but inside them this is the main wire, the copper wire, that is used for sending and receiving data signal. And if you say how we will configure, so we have those standard that refers to EIA TIA 568A or B. So if I show you 568B, this is the wire combination standard. This one, this is the A. Let me show you the B standard. This is the B standard configuration. So we will learn that, we will discuss that once we move in. And also I forget, there is another tool that is required to configure or punch those connector with wire. That is the clipping tool for UTP or STP. So here you can have that clipping tool. That's the clipping tool that we require once we want to install that particular wire. Here you can see that STP cable is being given, and also once you configure that wire, so we require a cable tester for RJ45 or that UTP. So basically that's the cable tester. Depends on the area, there may be different companies, the shape may be different, but we require that cable tester, that to check whether our configuration is proper or not. So that's cable tester you can use as well. So you may have that in your toolkit as well once you move into the real world or configuring those cables. Okay. Yeah, they are available online, or you may visit a local market. Not too much expensive, pretty much maybe depend, maybe $10, $15, around about there. Yeah, I have those those accessories with me from quite. Well, I have different stuff. In the beginning, I work as an IT professional. You can say IT technical support person initially. So at that time, I combine those different tools related to the IT support, those softwares, those backups. Even at that time, we use those imaging, Windows imaging software and all those stuff. But then once I move more advanced, so then again, with passage of time, I purchased different tools. So I have those. In general, I would say I have all those equipments, those devices. Even I have router switches with me, the Cisco routers and switches, which I use for practice and learning. I use them. So I have those. So it's a long journey. But with passage of time, once you move in, you, if you can, if you are, it depends on your buying purchase as well. If you have the buying capacity, purchase capacity, then you can buy. Otherwise, no need. The organization, the so which company, which vendor switches or router you have? Mm. Okay, so in real world, you need to have the Cisco routers, the Juniper routers, or maybe the Huawei or Microtech routers. Real world, I am saying. Mostly you will see, yeah, you will require the Cisco equipment as well. Exactly, but if I say again, I said that if you can, if you have the buying power, purchase power, so you can. But if doesn't, no longer required, no need. Okay, yeah. Well, if you studied, I don't know whether you studied IT technical support or not. But I will search my laptop. I will send, I think I have a document for the IT support. So I think with today, I think it's pretty much it. We have some other remaining topics, but we will cover that in a coming session. So hopefully, what we have covered today and what we have discussed today are pretty much okay to you at the moment. Or if you have any questions, so now you can ask me, so I can answer it. Support, yeah. Hmm? Okay, I will search if I found it my laptop, so definitely will share with you. Anything else?